To calculate the instantaneous rate of change exactly at any point x on the function f at x, we can use the formula, the limit as h approaches 0, of f at x plus h minus f at x all over h. Let's use it for the function f at x is equal to 1 over x to calculate the slope of the tangent there when x is equal to negative 1/2. So we'll use this formula that the IROC, or instantaneous rate of change, is equal to the limit as h approaches 0 of f at x plus h minus f at x all over h. In order to sub in here, we need to find out what f at x plus h is and what f at x is. So f at x is equal to, it's given to us, 1 over x. F at x plus h, what does that mean to find f at x plus h? It means take x plus h and sub it in for x. So wherever there was an x, instead in that place, put x plus h. So now we can put that into our formula. The limit as h approaches 0 of f at x plus h, so 1 over x plus h, minus 1 over x, all over h. The first step to evaluating any limit is to sub in h is equal to 0. But for every limit definition of a derivative, when you sub in 0, you're going to get an indeterminate form, 0 over 0. To evaluate indeterminate forms, when it's fractions, remember what do we use? We have to find a common denominator or use the Russian method. Let's use the Russian method here. So the Russian method says multiply every term by the common denominator. The denominator here is x plus h. The denominator here is x. Keep in mind those are different. And the denominator here is 1 because we don't see anything. So we want to multiply every term by x, x plus h. That's the common denominator. When you multiply this term by x, x plus h, the x plus h's cancel out. So that leaves us with x. When you multiply this term, or this term, by x, x plus h, the x's cancel out, leaving us with minus bracket x plus h. That bracket, using brackets are really, really helpful. It prevents you from making mistakes because now we'll know to distribute that negative in. And on the bottom, there's nothing to cancel with 1. So we just get h, x, x plus h. Let's simplify on top. We get the limit as h approaches 0 of x minus h, all over h, x, x plus h. What's the goal all the time? It's to cancel out h. So watch what happens. The x cancels out with this negative x. And now that there's only a negative h up top, this h will cancel out with this h, leaving us with not nothing up top, but negative 1 over x, x plus h. Now that we've canceled out the h, we'll be able to sub in. When we sub in, we're going to be subbing in for 0, not for x, because it's as h approaches 0. So you get negative 1 over x times x, or x plus 0. That leaves us with negative 1 over x squared. The derivative, negative 1 over x squared, it gives us the slope of every tangent on the function f at x is equal to 1 over x. When we sub in here, which one do we want to find? We want to find the value, or the slope of the tangent when x is equal to negative 1/2. So let's sub in, and you get negative 1 over negative 1/2 squared. When you type that all into your calculator, you get negative 4.